Okay, this video is about experiment 6A, analog to digital conversion. So we've made the measurements already, and again, this was the circuit that we used with voltmeters to show us the outputs of the digital lines, D7 through D0. So first thing we did was we took and we put a input of 2.55 volts in. This is what we got for an output. All the voltmeters except D7 were high, between 2 and 5 volts. Then we changed the voltages and got all these readings here. Okay. We then changed the reference level and got these readings. So the first question is the data word recorded in table number 1 what you expected. So let's go back here. It turns out it is. I mean, the reference voltage here is equal to 5.12 volts. I don't know how well you can see that. And our equation for the output is someplace here. Output in base 10 is this guy here. So we had 2.55 times 255 divided by 5.12 volts. Okay, and so what happens is if I do this math here, these will almost, if this was 256, we could cross that out and put a 2 here. So let's do that. Okay, and I take 1/2 of 255 and I'll get 127 or 128. Okay, 127 or 128 as the output base 10. So let's go back to this guy over here. The value of this guy is, this has a value of 1, 2, 4, 8, 16, 32, and 64, which will be, add those up, turns out to be 127. So we're right on the point where if we goose this up a little bit, this 2.55 to say 2.56, this one would flip over to a 1 and all these others would flip over to zeros, and we'd have 128. So we're right between 127 and 128. I made an approximation in the equation. You might recall a couple seconds ago I said if this was 256, it's not 256, it's 255. So actually I should get this guy 127 instead of 128, because it's a little bit less. Okay, so then what we do in this, we ask about a couple other questions. One of them is, so this is yes. What's the value of the least significant bit for the A to D converter? So what that is the reference voltage, which was at 5.12 volts, divided to the bit value. So total number of bits was 8, minus the bit number, which is 0. So that turns out to be 8 to the 8th, or 512 volts over 5.12 volts over 256, which works out to be 0.02 volts, 20 millivolts. So if I increase the voltage by 20 millivolts, I change one of the output bits. Okay. So we did this already. So what's happened? Measured output data word. So let's go back. One of the charts, the original thing, certainly I put 0 in. I got all zeros out. That's the 0 input. I should get a 0 out, and all zeros. If V in is 0. Let's take one. Let's do like 2.05. There's 0.34, 1.27, 2.05. 2.05. I had measured output was 0, 110 0110. So it kind of repeated itself. Now, in base 10, what that is, let's see, this has a value of 6. That's 64 and 32. 64 and 32 is 96 plus 6 is 102, I believe. Let me check my math here again. 64 plus 32 is 96, plus 4 is 100, plus 2 is 102. So calculated output. Well, the calculated output here is, from this equation, Vn times 255 over the reference. So let's plug some stuff in here. Vn was 2.05 volts times 255 over 512. Again, I'm going to take and simplify just a little bit here, and that little bit is this, that I'm going to take and call this 256, and divided by 512 I get 2 here, well 0.02 rather, 0.02, and if I divide up above the 0.02 into 205, I'm going to get 102.5. Of course, we got 102, so we should get 102 out, which binary again would be 0110, 0110. The only difficulty with all this stuff is sometimes this LSB here, the least significant bit, might be off by a factor of 1. Depends on what voltage you put in, what the reference voltage is, and stuff like that. Let's do one more. Let's do the down here we have a 5.08 volts. So the output was 11001100. So in decimal that would be 128 plus 64. 128 plus 64 plus 8 plus 4. So you can't see that. Let me move my camera a little bit here. So the calculation on the very bottom here of the 11001100. So that's let's see. I'm going to reduce this at all. Not really. Well, 4 and 128 is 132 plus the 8 becomes 140 plus the 64 is 204. So that's 204 is what the output should be, or rather what the base 10 decimal is calculated. So let's go back up here, move my camera again. So Vn was 5.08 times again 255 over 5.12. I'm going to work my magic again and get a value of let's see, 20. That's what it is. That's what I'm going to want to multiply. Let's see, what is this? 5 into that is 40. So it's 40 times 5.08. And that comes out to 203. Something like that. It's about 203. And we had 204. So it's close. Way down here at the bottom. 203. So if the binary is 203 is 11001001. So you notice that this least significant bit here is off by 1 versus this guy over here. Alright, so the only other thing is that we did the same thing over here. We have a new value of V reference is equal to 10.24. So you would do it the same way to figure out what they should be versus what they were. And they should be pretty close. Most they should be off by is 1. That would be the least significant bit. Okay, so much for this video.